Let's discuss finding the standard deviation by hand. In this case, we have a sample size of 10 drawn from a population. This is the data. We don't know what it represents. It doesn't really matter. Notice it's not in order. That also doesn't really matter for the standard deviation. When it's important when you're doing order would be in a frequency distribution, when you're creating a frequency distribution, or you're finding the median or quartiles or the 5-number summary. But the standard deviation is based on the mean, and the mean, you just add them all up and divide by how many there are. So it doesn't matter if they're in order. All right, so we have the steps as above in the notes. Step 1 is to find the mean. So we add them all up. And then divide by how many there are. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divide by 10. When you plug this all into your calculator, you get 78.8. Okay, so the next thing you do is subtract the mean from each of the data in the data set. So for example, we're going to do 77 minus 78.8. That's going to give us a number. So I'm going to list the numbers that it gives. Now, by the way, the mean is x bar. Second step is you would do xi minus x bar, where I is just like which one. So in the first one, this would be x1 minus x bar, and x2 minus x bar. Little by little, you'll see me create the formula for the standard deviation with this notation on the left. All right, so 77 minus 78.8 is negative 1.8. So this is just a list of subtractions. Where'd my mouse go? There we go. So, for example, 72.9, the next number, minus the mean, 78.8, negative 5.9. 86.2 minus the mean, 7.4. So I'm trying to keep these so that you can see the top one, and then when we subtract the mean, this bottom number, just for some kind of a structure. The next one's 16.4. So now I'm just going to speed up a little bit. This would be negative 11.25, I believe. Nope, negative 10.5, sorry. So let's just double check. This, I had a mistake in the notes in an earlier version, so I just want to make sure that I corrected it. There you go, negative 10.5, perfect. Negative 10.5, and then 95.2 minus 78.8, 16.4. Negative 15. I'm getting them a little bit off in the order of them. Negative 19.8. And finally 16.4. Let's make sure I didn't line them up very well. I'm missing one. So crazy. Now, good news is they don't have to be in order, but I really want this to look right, so you can follow it. So 75.2, that'd be negative 3.6. 95, that would be 16.4. 63.8 minus the mean is negative 15. 59 minus the mean is negative 19.8. And 95.2 minus the mean is 16.4. There we go. There's, we have this. These are basically the distance between each value and the mean. Now, when you do subtraction to find the distance, you will find some of them are smaller than the mean until you'll get a negative distance, and some of them are larger than the mean, and you'll get a positive distance. Now, we want to somehow average the distances these values are from the mean, and that's how we're going to get the standard deviation. However, we can't average them when some of them are negative and some of them are positive, because that doesn't give us a true reflection of how far on average they are away. So, what we do is we square these values. Third step. So, negative 1.8, what we do, by the way, if you know spreadsheets at all, you could do this pretty quickly with like Excel. If I square that value, we get 3.24. I'm not doing any rounding. Now, you might note that your question might ask for rounding, but you don't want to round in the middle of your problem. You want to round only the very last number. So this one's 3.24. Negative 5.9 squared is 34.81. 7.4 squared is 54.76. So what you'll notice as you do this is your numbers will all end up positive, but larger. 110.25, 12.96, 268.96, 225, 392.04, and 268.96. So now we have these numbers. We fixed some of them are negative, some of them are positive by squaring them. Now some of you might ask, why not do absolute value? And that does give you another form of measuring the spread, but it's not called the standard deviation. It's also not very nice to do with calculus, upper level mathematics. Calculus, this is a much easier version of measuring spread at that level. So this is what has been adopted. Okay, the next thing we do, and this is, so you know that what statistics essentially is taking a sample and studying the sample to get an idea of the overall population. Well, it turns out the standard deviation, when you do the sample of the standard deviation, it always undercuts the true standard deviation, the population's standard deviation. So one way to make the sample standard deviation better match the population standard deviation is in this next step. Step 4, we do what I call the quasi-mean. It's where we add them all up. That's what the sum symbol is. That's the uppercase Greek letter S for sum. And you divide by one less than how many in the data set. The dividing by one less has the sample standard deviation better reflect the true population standard deviation. So we would add up these 10 digits, these 10 numbers, and divide by not 10, but 9. So add them all up and divide by 9. And again, this is just a calculator step, and we get a long digit, a long set of decimals, is what I meant to say, like 4 5s and a 6. And I want full precision, so I'm writing down as much as I can. And now this is still based on larger numbers than the actual difference between the values in the data set and the mean. So now we get to the 5th step, which is the square root. And the formula just looks worse and worse and worse. But if you break it down into the steps, this is pretty straightforward. The square root of 182.2155556 equals 13.49872422. And so we get the standard deviation rounded to 2 decimal places, 13.50. We'd have 498 rounding up to 500, 2 decimal places, 49.8 up to 50, etc. That's our standard deviation by hand. Okay, now you get to try it. It's a much smaller data set, so it shouldn't take you as much work. Go ahead and pause the video and work this out. Okay, you should end up with 1.12. If you didn't, some intermediate steps, the mean, 7.72. The quasi-average, 1.247. And then the square root of that, 1.12. All right, I hope this helps you be able to do standard deviation by hand. I do want to point out this formula, when we divide by n minus 1, this is the sample standard deviation. If you divide by n, you do that formula if it's the full population standard deviation. And of course that means you took a census and you know everything about the population, and that's rare that you have that, but it is possible. So the sample standard deviation is the divide by n minus 1 step, whereas the population standard deviation would be a divide by n. All right. Thank you.